Electronics 101, and today we're going to be checking direct current circuits. So let's continue. Now, we shall define some basic concepts that are involved in electronics for this beginner lesson. So we have some basic concepts which deals with direct current. Direct current is given as a DC. Circuit analysis deals with a constant current, currents and voltages. While an alternating current, which is often given as AC, circuit analysis deals with time-varying voltage and current signals whose time average value is 0. Circuits with time average values of non-zero are also important and will be mentioned briefly in the section as we continue. So the DC circuit components considered in this course are constant voltage source, constant current source, and resistor. So electronics deals with charge, which is given by Q. So when we shall have a Q, basically we shall be dealing with charge. Electric, so we have an electric which will be given by E, and magnetic, which will be given by B. These are fields. So anytime we shall have a charge, will be represented by Q, and electric will be given by E, and magnetic will be given by B. Fields, as well as potential. Potential voltages will be given by V. We will not be concerned with the detailed description of these quantities, but we will use approximate methods when dealing with them. Hence, electronics can be considered as a more practical approach to these subjects. For details, we shall look at the classical physics and quantum mechanics course as we continue. Let's now define what a current is. So we shall check current. So this current is a fundamental quantity in electronics. Is charge, and its basic level is due to the charge properties of the fundamental particles of matter. So for all intensive purposes, it is electron, which is, or the lack of electrons, that matters. So the role of protons charge is negligible in this case. So the aggregate motion of charge is called I, which is given by I is the current, which is given by I. And I basically, remember we said, so this particularly is supposed to be Q. So is the change of is the change of charge with respect to time. So we say dq. So this is supposed to be Q here. So dq is the amount of positive charge crossing a specific surface in a specific time. So let's be aware that the charge in motion are actually negative electrons. Thus, the electrons move in the opposite directions to the current flow. So the electrons will move oppositely in the direction that the current flows. So if the current moves forward, then it means the electrons will be moving in the opposite direction. The SI unit for measuring current is given in amperes, which is given by A. For most electronic circuits and amperes, it is rather a large unit. So we shall break it down to a smaller unit of the amperes, which is now given by the milliamperes. So M stands for milli, then we have the amperes units, which is common. Now, we also have potential difference. So it is often more convenient to consider electrostatic potential V, that is the voltage, rather than the electric field as a whole, as a motivating influence for the flow of electric charge. The generalized vector properties of electric are usually unimportant. So the charge is potential in potential dV crosses a distance given as a change of R in an electric field. So it's given by this formula. So the change in the voltage is given by the negative of E, then you multiply by the change in distance. So a positive charge will move from a higher to a lower potential. The potential is referred to as a potential difference, or incorrectly as just voltage. So potential difference is just another definition for voltage. So remember that current flowing in a conductor is due to potential differences between its end. So electrons move from one point of less positive potential to more positive potential, that is voltage, as you can say, and the current flows in the opposite direction. So the SI unit for potential difference is given by V, which is just the voltage. Then we also look at resistance and the Ohm's law. So the Ohm's law, you say, for most materials, the voltage is directly proportional to the currents. But now we have a formula here given by V equals to Ri, and sometimes it's given by IR, right? So where V, which is the voltage, is given by V2 minus V1, is the voltage across the object. I is the current through the object, and R is the proportionality constant called the resistance of the object. So the resistance is a function of the material and shape of the object. The SI unit for measuring resistance is given by the ohms. So we can now we have so the ohms is given by that. So it is more common to find units in kilovolts and mega ohms. So the inverse of resistivity is conductivity. Okay, so the resistor tolerance can be as bad as plus or negative 20% for general purposes resistors to 1 plus 0.1%. So the ultra precision resistors for the ultra precision resistor. So only wire wound resistor are capable of ultra precision application. The concept of current through the potential across are key to the understanding of the sounding intelligent about electronics. Now comes the most useful virtual tool for this course. So I think for now we shall stop because that is just an introductivity of the topic. So thank you so much, and keep on watching, subscribe, share, and also